Hey student, we're in Unit 3. We're talking about other derivative rules, and today we're going to be talking about higher order derivatives. You may have seen y prime. Well, I know you've seen y prime. You may have seen y double prime. Today we're going to be talking about that and doing some problems associated with it. If we take the derivative of y, we write that as dy dx. We could also write it as y prime, but I'm going to focus on the dy dx here in the left. On the right, if we were doing it for f of x, the derivative would be f prime. Okay, if we're taking the derivative of dy dx, how do we write this? This is confusing for a lot of students, but I think it helps when we look at the d dx in front of dy dx. If we were to put all this together, multiply through, we would have two d's, d squared, just one y, and on the bottom we would have two dx's. So we could write it as d squared dx squared, but mathematicians decided that this was a little bit too much. We could also write it as dx parentheses squared. That's also a little bit much, so instead of that, we just write it as dx squared. So we're kind of shortening that, and it's a little bit improper, but I just want you to know what this is going to look like. It's not going to be dy squared dx squared. It's going to be d squared y dx squared. If we're taking the derivative of f prime of x, very simply, that would be f double prime of x. If we're taking the derivative of d squared y dx squared, we continue with the same pattern, d cubed y dx cubed. Okay, derivative of y double prime would be y triple prime. Nothing exciting there. D to the third, dx to the third would be d to the fourth y over dx to the fourth. And it would just continue like this on the left. Finally, if we're doing it of f triple prime, you'll probably start writing this just as f4 of x. So you'll stop with the tick marks just because it'll be too much at a certain point. Okay, so let's work out some problems. So f4 of 2. So we're going to take the fourth derivative of this function and plug in 2. So we'll take f prime of x. Bring down the 5. We have 5 over 30, which we could simplify, but I'm just not going to. 4 over 8 could also simplify. Plus 6x plus 1. 9 we don't care about. Goes away. F double prime would be 20 over 30 x to the third plus 12 over 8 x squared plus 6. F triple prime would be, bring down the 3, we would have 60 over 30 x squared plus 24 over 8 x plus nothing. 6 would go away. And f4, we would have, now I'm going to go ahead and simplify. 60 divided by 30 is 2. Bring down the 2, we have 4x. And we had 24 over 8 is 3. Just bring down the 1. We only have x to the 1, so we have 3. 4x plus 3. We just plug in 2 to this, so we'll get f4 of 2. It would be 8 plus 3 is 11. So our fourth derivative of this function, we would get 11. Now let's take the 100th derivative of x. Now, we're not going to do that. That's crazy. That would take forever. However, this is a problem where we could find a pattern. So we have f prime of x is equal to cosine of x. F double prime is equal to negative sine of x. F triple prime is equal to negative cosine of x. And f4, fourth derivative, fourth prime, would be sine of x. And then we'll just repeat from sine of x cosine, negative cosine. So we're repeating every 4. If it is a multiple of 4, then the derivative would be sine of x. F4 would be sine of x. F of 8 here would be sine of x. And 100 is divisible by 4. So, 100 divided by 4 is 25. So f 100th prime of pi over 6 would just be sine of pi over 6, which I hope you all remember is 1/2. Okay, yeah, no big deal there. So our last problem, we're going to find y double prime of y equals x squared e to the 4x. And here we notice we have to do the product rule. So we have u equals x squared, v equals e to the 4x. And you might already not be doing this whole process. I generally don't. I just think the derivative of the first function, leave the second alone, and then the derivative of the second, leave the first alone. But let's keep doing this process for now. U prime would be 2x. V prime would be e to the something is just e to the something times the derivative of the inside, which is 4. Okay, and so we will multiply across like so. We have 4x squared e to the 4x. This is y prime. 4x squared e to the 4x plus 2x e to the 4x. And you'll notice we now have to do the product rule again. We have to do it 2 times here. However, a lot of times in problems like this, we can notice something. We notice that this is the exact same as this. So we don't really need to do the product rule again. We just need to multiply by this derivative by 4. Now, I think I will do the product rule, just you can see it again, but we'll see that we're actually just going to replicate the same derivative here. So we could say u is equal to 4x squared, v is equal to e to the 4x, u prime, 8x, v prime, 4e to the 4x. So this would be the first part, just for this derivative. So y double prime, we have 16x squared e to the 4x plus 8x e to the 4x. Okay, and this derivative, we would say u is equal to 2x, v is equal to e to the 4x, u prime, v prime, u prime is 2, v prime is 4, e to the 4x. And we make our x, and we add. We have 8x e to the 4x plus 2e to the 4x. Okay, and now we can just combine like terms. It looks like we have 8x e to the 4x's. So we have y double prime is 16x squared e to the 4x plus 16x e to the 4x plus 2e to the 4x. Okay, and yeah, just one thing I was mentioning earlier, that 4x squared e to the 4x was the same as x squared e to the 4x, just multiplied by 4. And we can see that here, this is the same derivative. This is the same as what we had here, just multiplied by 4. 4x squared e to the 4x plus 2x e to the 4x. If we multiply this by 4, we would have 16x squared e to the 4x plus 8x e to the 4x, which is exactly what we got. So we didn't need to do the product rule again. We could just recycle that first derivative we already took, but it didn't hurt anything, and we ended up with our derivative anyway. All right, so those were some higher order derivatives. Nothing really special, nothing super new, just continuing the same process after doing one. Okay, well, I hope that helped, and I'll see you in the next video.